You see it hanging there after a storm, a massive, vibrant arch that looks solid enough to touch. But if you try to drive toward it or run to its base, it constantly recedes, always staying exactly the same distance away. It commands the sky, yet it has no mass, no surface, and casts no shadow. If this giant painted arch hanging in the atmosphere is not a physical object, we have to determine what is actually creating the image. To understand this effect, we have to look back at the earliest experiments into the behavior of light. Every arc and band follows a strict sequence of reflection and refraction, dictated by the way light interacts with water. Back in the 1600s, Sir Isaac Newton set up an experiment in a darkened room. He placed a solid glass block with angled, flat sides, a prism, directly in the path of a single sunbeam. This image shows the geometrical path of that light. As the white sunlight entered the glass, it bent sharply and expanded across a projection screen on the far wall. Newton's prism proved that sunlight is a composite, a dense bundle of individual colors traveling as a single beam until something forces them apart. The glass forced that beam to unpack itself, revealing a complete visible spectrum ranging from deep red all the way to violet. If a solid piece of glass can sort a sunbeam into its component colors, then a chaotic, messy rainstorm must possess its own mechanism for replicating this effect in the open sky. Let's follow a single beam of white sunlight plummeting through the atmosphere, past the clouds, until it reaches a single suspended drop of rain. The beam strikes the curved, transparent boundary of the water drop. Water is denser than air, so entering light slows down. This causes the beam to bend, a process known as refraction. The beam travels until it hits the back wall. Instead of passing through, the light reflects off the internal curve and bounces forward. That falling droplet acts as a microscopic optical trap. It captures the incoming sunlight, bends it inward, bounces it off the back wall, and redirects it right back toward the sun. This redirection separates the colors through dispersion, a property where water bends light at different angles based on its specific wavelength. Red light occupies the long end of the visible spectrum at 750 nanometers, while violet light is much shorter at 400 nanometers. Because of these differences, water slows each color down by a different amount, forcing red and violet waves to exit at distinct angles. As the separated colors leave the raindrop, they spread out into space along predictable geometric paths. The shorter blue and green light waves are bent the most, concentrating their exit path near a 40-degree angle relative to the incoming sunlight. The longer red light waves are bent the least, exiting the droplet at a steeper angle of roughly 42 degrees. Through this mechanism of dispersion, every falling drop functions as a precision-calibrated color sorter, broadcasting its own segment of the spectrum back into the air. When we zoom back out to the macro scale, we see a massive, chaotic curtain of falling rain. For the colors to align, the geometry must be perfect. You need millions of water droplets in front of you, with the sun positioned low in the sky directly behind you, casting its light over your shoulder. Because red light exits at a steep 42-degree angle, it only reaches your eye from droplets high up in the sky. Meanwhile, blue light exits at a flatter 40-degree angle, so it comes from droplets lower down. This unyielding geometry is why the arch is always universally ordered, with the red band stacked firmly on top and the blue band locked at the bottom. The physicist Richard Feynman spent a lot of time thinking about the beauty underlying these mathematical laws. He recognized that the optics of the rainbow create something far more interesting than a simple painted arch. Feynman realized that the rainbow does not exist as a physical object. It is a cone of light that is entirely unique to your exact physical location. If you take a single step forward, your viewing angle shifts. The raindrops that were sending you red light a moment ago are no longer in alignment, and a completely new set of drops instantly takes over to project the colors into your eyes. You are witnessing a delicate optical alignment playing out against the massive scale of the natural world. The arc exists as a temporary alignment of physics, a phenomenon that is rebuilt every single second and is unique to the exact spot where you stand.